Hello everybody, and welcome back to the channel. At long last, we're continuing with the Raylib series. So today we're going to spend some time talking about a tic-tac-toe in Raylib. This tic-tac-toe is going to be pretty simple. It's going to be kind of like more of a share the mouse kind of thing. So player 1 and player 2 will both be locally, and it's going to be very minimal. It's really just about taking some existing code and transforming it into something new is kind of the primary theme. So in conjunction with that theme, I've gone ahead and copied the project folder that I used for the Minesweeper. So this is all the Minesweeper code from the video we made. I believe it's been slightly expanded on and modified since the video, just adding web support so that I could get a web build to link to from the video. So I'm going to quickly go through and remove a bunch of the elements that we're not going to need in Tic-Tac-Toe, and then we'll talk a little bit about it and get started on changing the game logic from being Minesweeper specific to Tic-Tac-Toe specific. So I've just run through the code, and anything that we are not going to use at all, I've completely removed, and I've avoided making any actual changes to any existing code. Like I didn't, there's some code that we're going to want to use similar logic, so we're going to want to transplant it, but I did clear cut, so completely just delete lines of code that were completely unnecessary. So just as some examples, I deleted and all of the camera logic. We're not going to have 2D camera, anything like that. There's no need for that. So all the camera logic and any of the dragging logic has been removed. Anything or almost everything specific to mines revealed. So anything about mines or counting the neighbors and all that stuff is not relevant to this game, so it's been removed. Really, the code that I'm trying to preserve is the interactive of being able to say which cell is being clicked on, having the system of a grid of cells that make up the game, and beyond that, the logic has been largely cut down on. So there's a bunch of things we're going to still want to change. So for instance, tic-tac-toe is 3x3, so I'm going to change the columns and rows to 3 and 3. This you lose, you win, press to restart. So it's not really going to be you lose, you win. It's more player 1 wins, player 2 wins. So we're going to change these accordingly. I'm using the F2 rename symbol functionality to be able to rename all occurrences of it. Okay, so we got those constants are set up. Now, for the cells, we still kept the indices, but we also need to be able to track what value is actually in the cells. So we'll just call it a cell value struct. And it's going to be not a struct actually, I'm sorry, it's going to be an enum that is going to either be empty, it's going to be an X, or it's going to be an O. So we can use this enum within the cell to denote its value. Now, tiles revealed, we're actually going to change this to tiles occupied. And this is just going to tell us how many tiles have been filled. So with a tic-tac-toe board, I'll just do a really awesome drawing here. If we were to play in such a way that we're trying to end the game as fast as possible. So let's say the player 1 and player 2 are working together and saying, let's end the game as quickly as possible. So X may play up here, O will play down here. Now X will play here, O can play here, and now X can win if he plays here. And this will end the game. So that's the fastest possible win. The players are not actually trying to interfere with or stop each other. So on any move that is less than 5, so for example on the second turn, it's either move 3 or move 4. And on that turn, it's impossible for the game to end. So we actually don't ever have to check the game logic until we've made 5 moves. And that's a simple optimization we can make. So that's why we're going to keep this value. And remember, I renamed the symbol, so it's still going to be hopefully in the right place in the code. Some of these other things are just helpful statistics. We may or may not use them when the game started, when it ended. And then for the functions, this is what's left. So we still need to be able to draw the cells. It's still helpful to know if an index is valid before we do any kind of processing with the input. Then we have cell reveal. I kept this, but we're actually going to want to change it to cell mark. And we're going to want to add a cell value parameter. Now I'm going to jump to the definition of this function. And just add cell value so that the errors will go away. We can keep working. So that's the change to cell value. We'll change it, or to cell mark, whatever it was called. I already forget. I was just looking at it a second ago. And we're still going to keep the grid in it and game in it, but of course the logic is going to largely change in these. Now, skipping ahead to grid in it, since that method is actually done, I only had to delete. I deleted some of the initialization of some of the values, but keeping grid in it, setting the state not to playing, but to player 1, because we need to change the game state. I totally forgot. It used to be playing, lose, and win, but since it's a 2-player game now, we want to track whose turn it is. So player 1, player 2, and then we'll just call it end. So changing all of the values here. We want to set the starting state to player 1, because of course player 1 gets to go first. Tiles occupied is 0, and time game started. So game init, we didn't have to change much. Grid init, I only had to do deletion. I didn't have to make any changes, and this is almost exactly what we want, except now we want to also set the value to be empty, since all the cells should start out empty. And that's the grid init. By the way, I should mention, I'm going to move a little fast in this video, because I'm assuming you've already watched the Minesweeper video. Now, I will apologize that the Minesweeper video drags on, and that it is quite quiet. There's not much I can do about the volume now, so I do apologize for that. But in that video, I explain much more what's going on with a lot of this logic. So you can either pause and read the code. You can check out the GitHub for the Minesweeper project and read the code there. And if you have questions, then yes, you can watch the video, of course, or you can even ask questions in the comment section of this video. But I'm trying not to revisit anything I already covered in the Minesweeper video. I'm trying to be swift. So cell mark, there's all this logic about whether a grid is flagged or revealed, then we don't let you play on it. And if it contains a mine, we lose. If it doesn't contain a mine and we've actually hit the last mine, then we win. So here's the thing, okay? You want each function to have one responsibility. So index is valid is a bool, meaning the only thing it really needs to do is tell us information about the parameters. And it does that. It returns a bool statement immediately, and it's a very simple function. Cellmark had 2 responsibilities. It changes the state of the grid array, as we can see here on line 100. But then it also is changing the state of the game, changing it to lose, changing it to win. Sometimes it won't do anything because it's possible that this if statement fails, we go to the else, and then this one fails, and the game continues. And the caller of the function knows that if the game's supposed to end, it will, and if the game is supposed to continue, it will. And there's no real communication. So what we really want to do with a method like cellmark is actually send information back up to the caller and let them know, hey, they were able to mark there, or hey, they were not. And but we're going to change the logic a little bit around that because it's a cleaner solution. But another thing we should mention probably is that all of this logic is pretty much totally wrong. So we're actually going to restart with this one pretty much. I'm going to go just to revealed equals true. The rest of this is going to go away. So if grid at ij is flagged or revealed. So what we really want to write is if the value is not empty, and I also want to check against that the value we're passing in is also not empty. So if there is something already in the grid space, or if we're calling this method with an invalid value, such as empty, then we can just return, but we're not going to return, we're going to return false. Because like I said, we want to send a message back up to the caller and see what is actually what we can find out what effect the function had on the game state by actually checking that value. So we're going to return false if we did not mark, and then in this case we're going to set the value of the cell to the value that is being passed in from the function, and we're going to increase the tiles occupied value, and lastly we can return true. So this was the change to cellmark. So totally restructured it, but we still wanted to keep this ij, so that was very helpful. Index is valid. Like I said, we have nothing that we need to change here because it's based on the columns and rows values, which we were able to change earlier in the file. So all of that is good to go. And cell draw, I deleted pretty much everything so that we only just draw rectangle lines for each cell. So ideally, we would have some logic here to draw maybe a sprite that we have or something like this. So what we are going to use sprites, and we're going to get into that in a moment. But for now, let's just write in the code that we're going to need here. So we're going to switch the cell's value. And with the switch statement, we need to write every possible value that we want to monitor. So thankfully, it's an enum, so it's pretty easy. We have the case of empty. And then we have the case of X and the case of O. So when we call this method and it switches on this value, if it's an empty cell, it's going to run whatever code is between this case and this break. If it has an X, it's going to run at whatever code is here. And if it has an O, it's going to run at whatever code is here. Now, with the way enums work, if it's not any three of these cases, it will draw nothing. And the truth is that in the empty case, we want to do nothing. So instead of keeping this as an empty case, I'm going to move it to the end. And instead of using this case, we're going to write default. So default is basically for any value that isn't covered above it. So for this case, we'll use this, for this case. And then at the end, if we run out of everything else, we'll just say default. So this is kind of like a none of the above. I don't think the order is actually important, but generally, I think this is a good way to write it. Write all your specific cases at the top and then write the catch-all at the bottom, since it's kind of like, imagine if it was an if-else statement. You'd want to put the generic case at the very end. So in the default case, we do nothing. The truth is we can also write it like this. We can have no default case. And then that way in the empty case and in any other value that is not X or O, we will draw nothing. But I think it's helpful to explicitly write default just so that we can see that we've considered that case. If we don't write it, then it's kind of like what's going to happen. But I'm being explicit. And generally speaking, being explicit is good practice, especially when it comes to game dev. If you plan on sharing your code, if you want to use your code as a kind of learning resource, or if you want to collaborate with others, it makes sense to follow these kinds of rules. So we're going to go ahead and just throw in a to-do here. Because we're not there yet. We got other things that we want to worry about. We want to worry about some more of the game logic first. So there's not much else to do. In main, there was not anything else that really needs to happen here. I guess I need to... I don't know. Do you capitalize it like this? I'm going to do that. The beauty of the way that we wrote the main method before is that nothing actually needs to change. There is some generic initialization method. If the window shouldn't close, we run the update. And finally, when we click the X button, or if some other signal that says we need to close the app, then we'll call close window and we can return 0. If we were loading any kind of resource, we'd want to unload them here. I don't think I was doing that in the Minesweeper project. So we're going to make sure we do that this time. But that's all for main. So now it's right into the update draw frame. So first things first, if we click the left mouse button and we actually, on the frame that we release it, we have this get screen to world 2D. So this is interfacing with the camera. I left this because I want to show how to get away. So if we're not using the camera anymore, we can just go back to using the raw get mouse position value, and that works great. We don't want to say if state is playing. We want to say if state is not end is when we allow a cell mark. And of course, we need to require that the index is valid as well. And we can call cell mark, but we need to make sure to put in the correct cell value. Now, in this case, what I'm going to write is state equals player1. Then we will use X, otherwise we will use O. So this is a ternary operator. So if this statement is true, it's going to return this. And if this statement is false, it's going to return this. So this is short form for writing basically this, having cell value if player1 There we go. So just by writing this little statement that's highlighted here, we're able to emulate all of this functionality. If cell value, if player1, da-da-da-da-da. We can do all of this in this one place. We don't need to declare a variable. We don't have to do any of these kinds of things. We can keep it real simple. Sometimes it makes this kind of thing more unreadable, but this is a pretty old operator. It's been around for a pretty long time. Now, if the key R is pressed, we restart the game. I'm going to add a stipulation here that state needs to equal end. Because if we don't have this stipulation here, then the player can reset whenever they want. And since it's going to be two people sharing a keyboard and mouse to play this game, I think it would be kind of rude if you were losing and you just hit R and you reset the game. I don't think most people would be very happy about that. So that's all of the update logic of the game. Now it's really just going to come down to the drawing. So if the state is lose, we used to draw how long the game lasted. I'll keep all this logic, and that's fine, but it needs to not be lose, it needs to be end. And the irony is that we had this whole lose, draw this text, and win, draw this other text. So instead, I'm going to copy this logic over. I'm going to just delete this whole case. So remember this, okay? This was the case if we had like won the game, I think, and this was the case if we lost. So what you'll notice is since I did that rename, it says player 1 and player 2 wins instead of saying win and lose. So if the state is end, then we need to see basically who won. So if winner equals player 1, we're going to have to add a winner field as well. Else, now here's something interesting to note is that all of these values, screen width divided by 2 minus measure text, all of this is actually the same. So maybe what we should do instead is have a character pointer called text and set it equal to, and use our fancy friend the ternary operator. Winner. So if the winner is player 1, then we use player 1 wins. Otherwise, we use player 2 wins. And now we can actually use all of this common code. And all we have to do is replace every occurrence with player 1 wins with just text. So now we just need to actually define this winner value. So I'm going to go back to where we define state and do it right here. So I'm going to write another game state called winner. Make sure to make this a constant character pointer since the original player 1 wins and player 2 wins are both also constant character pointers. So here we go. This is the simplified if the state is end. So we kind of combined the other two bodies into this one body. So that's pretty neat. So the only thing that's really left is we need to make sure we're monitoring this cell mark value and we need to use it accordingly. So if cell mark, and we need to make this into its own thing. So if this returns true, then we actually want to change who the current player is. So state is going to be equal to is player 1. There we go. We're going to use another ternary. This video is all about ternaries. So if the current state is player 1, we're going to set it to player 2. Otherwise, we're going to set it to player 1. Okay? So but what this is doing is it's going to flip-flop between player 1 and player 2. So imagine in the first case that the value is player 1. So if the value is player 1, then we're going to send an X through to this function. It's going to return true if it successfully marks the cell. And now we're going to update the value of state. So since it was player 1, it'll now be player 2. And we'll switch back. So we've done a lot of stuff, and we don't really know if it's going to work. So just to test the whole game, usually you want to test more often than this, but I'm feeling particularly confident today. We're going to use our destination rectangle, and we're going to draw a red rectangle for X and a blue rectangle for O. Okay, so remember, we're not going to have any messaging on screen that tells us whose turn it is, but we're going to be able to just click, and we should see alternating red and blue when we click. And hopefully, if we click one that is occupied, it won't change. I have no idea if this is going to work. I'm going to go ahead and hit F5, and we'll give it a shot. Okay, so we've got a 3x3 grid. That's the first thing that's right. I'm a little nervous. Oh, never mind. The cursor was doing that thing, so I was a little nervous. Here we go. Let's click, and click, and click. Now I'm going to click this again and click it. We should still get red. Okay. So it looks like, for the most part, our things are working. Now, what we're going to do next is we're going to put some text on the screen that says whose turn it is, because I think that'll make it a lot easier to know what's going on. So down here, if state is end, we do that. Otherwise, let's have another case. Now we're going to do the same kind of constant character pointer switching. except in this case, we're going to see what the current state is. So if the state is player 1, then we're going to say player 1 turn prompt. And we're going to do the exact same thing for player 2 in the event that it's player 2's turn. So we got to go ahead and define these now. Player 1 go, player 2 go. Okay. So we got our prompt set up. We're switching between them, and now we want to do pretty much the exact same text here. And I'm not going to change any of the other settings. I'm just going to leave it like this. I'm sure I'll want to tweak the position, but let's just see if that works for now. Player 1 go. Okay, well, we still have the press R to play again. Oh, I see. And the rectangle is over the entire screen. Okay, so we're getting somewhere. I see. 0, 0, screen width, screen height. Okay, let's define a rectangle that we want the text to go in. And I can draw the rectangle only in that area. Okay, so I've defined a rectangle which is at screen width by 2, which means it's in the middle of the screen horizontally. Then I offset it by the length of the text, and I'll want to divide this by 2. Then I remove 40 as padding. Then we have the screen height by 2 minus 10, so it's a little bit above, or a little bit below the middle of the screen, I guess you could say. And then we have the width of the text plus 80, because I want 40 on each side for padding, and I want 80 for the height of the rectangle. So hopefully that will do an okay job. I realize now if I'm doing 80 padding, I want to do minus 40 here for the rectangle. So instead of drawing some generic rectangle, we're going to draw a rectangle rec, and we're going to use the text rect that we just defined. I'm going to remove the press R to restart since we're not using it anymore, and I'm going to make sure that my position of the text is the same as I kind of planned this rectangle for. So screen width by 2 minus measure by 2. That all looks good. Screen width by 2. And we're just going to leave it. We're not going to do a minus anything. Actually, we'll do minus 20 since 20 is half of 40. Make the font size 40 and make the text dark gray. Let's go ahead and render, or I should say compile, and we'll see how it looks now. Okay, it's pretty good. The only thing I want to do now is I want to move the box, but having to change the value in both places is kind of annoying. So what I can do is I can say vector2 message position. And I can set the message position to be exactly where I want the message itself to be. So so I'll do exactly what it was before. So screen width by 2, screen height by 2. And now we're going to change this to use the X and Y of the position. Okay, so now I'm going to compile once more, and we should see no change. Okay, cool. And now the last thing we need to do is choose the actual position I want to use, which is not screen height by 2, but actually just 40, so that it's at the top middle of the screen. Okay, that looks pretty good. So now we know whose go it is. And I'm spam clicking right now, but it's not changing because the tile is occupied. Now, I've gone ahead and added a little really bad sprite that I made really quick, which just contains an X in the first 100 by 100, and then contains an O in the second 100 by 100 of the image. You can see how I authored it in a sprite very, very, very simply, but it's exactly 200 wide, 100 tall. And we're going to need to know that so that we can properly use these as an atlas. So moving back to the code, I'm going to go ahead and close the game. The first thing I'm going to want to do is load these new resources. Thankfully, it's just the one atlas that we need to use. In main, we're going to set the atlas equal to load texture, and we're just going to go ahead and write the name of the file. I can switch to project view here so you can see in resources I've added a file called tic-tac-toe.png. So we load the texture, and something I forgot to do before we close the window, we're going to want to unload the texture. So after this loop, but before we close the window, we want to make sure we unload the texture. It doesn't matter if we're closing the window anyway, at least I don't think, but it's just good practice. Again, being explicit, we want to make sure that we do that. Now, in cell draw, we can use our new information. So instead of doing rectangle rect, we want to say draw texture pro. So we need a texture, the source, the destination, and the origin. Now, thankfully, we've already got the destination, but the texture is going to be Atlas, and now we need the source. Now, the source is going to vary based on which rectangle we're using. So I'm going to write here, rectangle source is equal to, and I'm just going to make it a 0, 0 rectangle, just so that it has a default value and the compiler doesn't yell at us at some point. Now here we're going to override the value to be, so for the X, if we review the image that I made here, the X is the first image, so it's going to be at 0, 0, and it's 100 by 100. Now the second image that we made, the O, is 100 pixels to the right. So we just write 100, 0, 100, 100. And that will be the rectangle that we need. So we can use the source, the destination, and now we just need to see what's left. So I believe we need to give an origin. I will just give 0. And then we need rotation. I will give 0. And tint, let's start with black. This Draw Texture Pro is actually the exact same code. So the only thing that's really changing between these two cases is what the source rectangle is, but for simplicity, I don't want to have a Draw Texture Pro down here in the default case. So we're just going to keep the code copied into each spot. Okay, let's see if that's working properly. Okay, I'm not seeing it, but I am seeing failed to load file. So I realized in main, I actually put Tic-Tac-Toe, but it's actually resources/Tic-Tac-Toe. Okay. So we've got X's and O's actually appearing, and X wins. Obviously, we don't have the logic in to say who wins and who loses, but we're getting pretty close. We've got the visual differences of it. Now, notice how I made the image. I made the shapes very deliberately white. That's because white can be tinted any color. So if you decided that in your game you wanted that one to be red and the other to be blue, you actually can use that. And I'll just run it one more time and show you that we can make the X is red and the O is blue, just to give it a little more contrast and a little more excitement. Okay, so like I said, we're actually really close. We just need to add the logic of checking who wins, and that may be the trickiest part, but, well, let's take a look. So the trick is right here. When we switch the state of the game from being one player's turn to another player's turn, that's when we want to actually check the logic of the game. So what we really want to say is if game is over, if it's not, only then do we switch the state. Otherwise, we want to set the state equal to end. And we also want to have some way of determining the winner. So provide a pointer. Yes, that'll work. So game state is a value. And if we put this address operator before, we're going to get the address of this thing. So we can provide a pointer to this new function we're going to add, which is game is over. Game is over is going to find out if the game has ended, if there is a winner, and if it is, it's going to assign the value to that winner thing. So if the game is not over, then we're going to switch to the next player and move forward. But if it is over, then we're going to set the state to end, and we'll already have set the winner accordingly. So let's go ahead and create this new function. So we want to take a game state pointer. So we have our bool game is over. We're going to get an error because we're not actually returning. Well, first of all, the first one is because we're not providing a name for this parameter. And the second error should be, I'm not getting one. I guess this is just Visual Studio Code, isn't the perfect IDE for C. But this is actually wrong because we're not actually providing this return type. So we're just going to go ahead and return false just as a default. So basically what we're going to want to do is we're going to want to check the diagonals and then check each horizontal line and check each vertical line. And so after we've checked the diagonals, each horizontal line, each vertical line, if at any point during here we find a line, we'll return true and we'll assign the winner. But if after all this time we do not have the value from all this, then we could just go ahead and return false at the end. We don't have to worry about anything. Now, in the case that we return false, we do want to set the winner to something. Now, I've actually changed my mind. I don't want to use game state. I want to use cell value, because the cell value is going to be what's in the cell. And I think what's in the cell denotes the player in a more accurate sense than like whose turn it is, right? And in the same vein, having player 1, maybe it's player X and player O. It's just, I think I want to sort of reduce any potential for confusion. So we want to set winner to empty. But we want to do a little asterisk first so that we actually change the value at the pointer to empty. But in all these other cases, we're going to want to do something else. So let's start with the diagonals because they are hard-coded cases. So this one's pretty easy. So if grid at 0, 0 equals grid at 1, 1, and grid at 1, 1 equals grid at 2, 2. If this one equals this one equals this one, then we have this diagonal line. Okay? So that's what this case that I've just written here is. And the other case would be if 2, 0 equals 1, 1 equals 0, 2. And that's the other line going this way. We can't actually equate the grids directly. We need to equate their value. So just make sure to add dot value to each of these. Okay, so if grid 0's value equals grid 1, grid 1's value equals grid 2, and there's one more requirement, that grid 0, 0 is not empty. And actually, we can put this first. So in order for the top left to bottom right diagonal, top left, bottom right diagonal, to be a winning spot, the top left needs to not be empty. So if the top left is not empty, and each of these other ones have the same value, then we know that they're all not empty, which means that it's going to be potentially a winning value for somebody. So that's one diagonal. Now let's quickly write the second diagonal, which is going to be the same thing, except we want to go 0, 2, 1, 1, and then 2, 0. And that's, so we'll actually write these explicitly. So this is top left, bottom right. This one is bottom left, top right. And now it's going to come down to the horizontal lines. So you can do this in a loop, but I'm just going to write these out exactly, and it's actually going to make it easier to draw the line to show who the winner is later as well. So I'm going to start by copying this if statement. So with this visual aid in mind, we're just continuing, and I'm laying out all of the different lines. So left middle, right middle, and now lastly we have bottom left, bottom right, and we just need to change all of these 1s to 2s. So that's the horizontal lines, and now lastly we just have the vertical lines left. So we have top left to bottom left, 0, 0, 0, 1, 0, 2. Now we do top middle to bottom middle, and top right to bottom right. Okay, so in each of these if statements, we've basically arrived at a case where it's the case that if we land here, that means that somebody has won, and that is the line they've won on. So who has won? Well, the winner resides in any one of these values. So I'll just always go with the first one. So grid 0, 0 dot value is the winner, and we will return true. Now we just need to propagate this through to all of these. And I'm going to make sure that I'm always going to copy whatever the index is of the first value so that we are getting the correct example value. Okay, so we've set up all of the different cases here. And once again, I encourage you to check out the GitHub page for this project if you're struggling to follow along. I know I'm kind of zipping through some of this stuff. So now each case has been taken care of, And so game is over is going to return true if the game is over, and it will have set the winner. Now, the only thing that's left to do, and I mentioned this already, was we don't need to do this logic if it's under a certain turn. As it stands, we're not actually doing that. Okay, so we've changed a lot of things again. So what we're going to do is we're going to hit F5 and we're just going to see what happens. Oh, I just spotted an issue. Okay, player X, player O, player X, player O, player X. Player X wins. Player X, player O, player X, player O, player X, player O. Now, in this case, nobody wins. We haven't covered the cat's case, but it really seems like that's the only case. So I will just say game is won. I'm checking this, or sorry, game is over. I'm checking this even when it's not possible for the game to be over yet. So I'm just going to quickly change that here. So what I've done here is, I believe it was called short circuiting when they taught it to me in school. Basically the idea is I'm using an OR statement, and with OR, only one of them needs to be true for this to return true. So only one of these needs to succeed. Tiles less than 5, or the game is not over. So we're not even going to do the game is not over logic if the tiles occupied is less than 5. So we're going to skip doing all this work. So if tiles occupied is 0, 1, 2, 3, or 4, we're going to skip this. And it'll actually never even execute this, because if this is true, true or anything is true. So we're going to skip having to do that check, and we're just going to move right on to doing the next turn. Okay, still works on the first turn, so that's good. The only two things that are missing now is we need to fix that we don't have a cat's case, and we need to fix the time played. So here's what's going to happen. I'm going to put up the code as it is now on GitHub. I'm going to give you, the viewer, some time to clone it or whatever and try it locally on your own and see if you can get the cat's functionality and see if you can fix the time played. Who knows what the problem is there? I haven't looked at it. Fix the timer, add a cat's case. Those are some things you can do. Something else I might want to try in the video is have some logic to check if the game is unwinnable. Because in this case here, then O and O. So O has no move right now, or sorry, X has no move right now that could win. X and O have both lost. So this is also like a cat's game. It's a losing scenario. It may have been possible to know it before O played. So setting up some logic like that, I'm going to avoid something like that, but that's another thing that I encourage you to try setting up on your own. I would expect like a real good modern tic-tac-toe to be able to do. There's also, I left all the resources in from the Minesweeper project, so there is some sound effects if you wanted to try throwing sound effects into the project. There's a million other things you can do. I plan to make a follow-up video where we can fix up some of the issues, you know, get the cat's game, maybe add that checking logic. And another thing I want to say here is go ahead and like the video if you liked the video. If you watched to this point, I'm assuming you liked it. And feel free to subscribe. I'm going to be making, I have a few other great Raylib projects in mind, and eventually I may branch out from that as well. So thank you so much.